Good day, ladies and gentlemen. I'm Otis, a pre-sales engineer at Sencore, and I will be your host today. Thanks for taking the time to join us. Today's topic is Commercial IPTV Network Masterclass, building stable, high-performance system for hospitality and critical environments. Before we begin, I'd like to quickly go over a few housekeeping items. During the presentation, attendees will stay muted to avoid background noise. If you have any questions, please type them into the chat at any time. We'll collect your question and adjust them during the Q&A section at the end of the presentation. Thanks in advance for your cooperation. Now, I'd like to introduce today's speaker. Our speaker today is Terry Zhou, Sencore's Hospitality IPTV Product Manager. Terry will share practical design tips, common technical challenges, and real-world product experience. Terry, thanks for joining us. The floor is yours.
Okay, so welcome to join the webinar, and good morning and good afternoon for all of the precious customers and engineers to join us. Yeah, so today's topic is a commercial IPTV network. So actually we have in daily life, when we deploy the IPTV system in different facilities, no matter it's hospital, hotel, cruise ship, residence area, we may encounter any risk of IT network issues, right? So today's class is mainly to introduce how of IPTV streaming, the content, how we should separate our network and the corresponding technology used for such applications. So I give you a big picture of how IPTV system is composed. So as an IPTV system, so we have a content source. So typically we have content source, IPTV server, and we have core switch. And in different layer of the building, we may have access switch. And down then we have either an JOS set-top box plus a TV set, or we are using, we can use directly the Samsung, LG, or any other brand hospitality TV. So this is the main connection of the network. Of course, inside the room, we also have other network, like we have wireless AP for internet access. We may have SIP phone that for telephone service. And all of this content actually was separated on the network. So, from as an IPTV system, the most important part is the content source. We have a live content. So where's the live content from? Typically, we can use only have 6 or 16 receiver and encoder product to receive all this content. Typically, we can receive the content from satellite, either FTA or scramble content. We can handle, we can decrypt, we can receive, and we can convert them UDP multicast stream. And we can also receive the content from terrestrial signal source. So no matter it's DVB-T, T2, ISDBT, different standard. We have receiver modules that can support almost all the international standard for the receiving part. And we can also receive the content from a cable operator. So the DVB-C signal, for instance. So we can also receive them, decrypt them, and then convert to UDP multicast. And sometimes we can receive the content from IPTV content provider. They can simply provide the HRS streams or UDP multicast streams via MPLS technology to transmit from their central station to each hotel, hospital, or other entity. Or sometimes they can use a satellite receiver with HDMI output or any other output. Then we can use an encoder to achieve the encoding and then convert to UDP multicast. So this is on the content source part for live channels. We can use only have 616 to achieve all the conversion. So all the content before it's streaming before it can be streamed properly to the TV set or to the Android set-top box, all the content will be converted to UDP multicast stream first. And next part is streaming part. So streaming part, typically we can use two kind of protocols. One is the UDP multicast directory. We can push the content source directory to the terminals, and IPTV server will play the role as a management, stream management and control, and also provide additional service for the like VOD. VOD typically use HRS streaming to achieve the content transmission, and also for some hotel introduction like a welcome page, some welcome information, some hotel facility introduction with pictures and introduction information there. And also the IPTV servers can integrate with, has already integrated with third-party PMS system like Opera PMS, like Tiger TMS, such kind of third-party TMS that has already deployed in this hotel or in this facility. And also this IPTV server can be triggered with an emergency alert system, no matter it's a US ES standard triggering signal or any other fire alarm triggering signal. Our IPTV system can accommodate. And other than that, actually, we also another most important protocol is the HRS. Of course, we have other projects that deployed MPEG Dash. But the HRS is still widely used for streaming, especially for the network that has not been properly managed. Yeah. So, but for the majority of project, UDP multicast is dominant because the stream do not have to be further processed by the IPTV server. So it can decrease the burden of the server and or increase the number of terminals with the same hardware. So HRS streaming is typically used for some networks that is not IGMP ready and not properly VLAN separated. So such kind of networks, if they may consider to use HRS, or the network is not, the number of terminal is not very large, then they can use HRS. And also for the, so this, after the IPTV streaming part, then we can go to the switch. Typically, if we are using UDP multicast as a streaming protocol, then we have to separate. We have to separate the VLAN with the internet data, because typically internet service is a base service for instance, for a hotel facility. So they will use a dedicated VLAN, and also they for the content source, UDP multicast, they will use a designated different VLAN. The reason to use a VLAN is that because the multicast actually can flood the network sometimes if the network is not properly configured. So usually for the TV service, especially for the UDP multicast stream service, they will use a dedicated VLAN. So as the IT engineer, it can simplify the work for the IT engineer. Any problem with TV service will not influence the internet service, or the internet connection issue will not influence the TV service. So VLAN plays an important role for that. And other than that is IGMP query and IGMP snooping. This function actually, because whenever the TV set-top box, if you do not have the IGMP snooping, then whenever there's a request or that's a multicast string running inside our switch, all the string will be running in a broadcasting mode. So it will flooding the network. But with the IGMP query and the IGMP snooping enabled in the switch, then all the content is properly managed, and only the request, only the terminal requires a designated multicast IP stream, then it will transmit to that port. So it can be properly manage all the data flow, and also on the receiving side, the bit rate of the TV channel will not be very large. So each time it will have transmit only the bit rate of the TV channels. For instance, typical video TV channels, the bit rate H.264 encoding. For standard definition, it's 3 or 4 megabits for high quality, and for premium quality, like 6 to 8 for high definition. Yeah. And another part is wireless AP. Wireless AP is typically use a dedicated VLAN. So because in each room typically there's SSID for internet access. Okay, so next one, DHCP. So DHCP is typically used for the dynamic IP address assignment. So typically, that's if that's a third layer, layer 3 switch, or that's a router inside of the network, then that router or layer 3 switch will play the role of DHCP server. And actually, our IPTV server also has a function to play the role as a DHCP server, but depends on what you need. If your network do not have the disabled DHCP server, then you can use the function DHCP server in our IPTV server. And the main the DHCP actually called dynamic host configuration protocol. So the main use of this protocol is to assign automatically the IP address. So you do not have to manually configure the IP address of set-top box, IP address of the TV set, which is very time consuming. And the DHCP works with the 4th step called the DORA process. So the first step is discover. So typically the set-top box or TV set will make a request. I need an IP address. Is a DHCP server available to help? Then when the DHCP server receive this request, then they will offer a certain IP address they will offer you one address to then the set-top box TV set automatically assign that IP address. And after further, then that's a discovery, offer, and a request, and finally make a acknowledge of that IP address. So typically, once the IP address is assigned, it will take a certain period of time. We call aging time for the IP address until next aging time, and they will make this DORA step at another round. Yeah, typically DHCP is very useful for larger networks that we want to automatically assign all the IP address for the hundreds of terminals. Another main topic is IPv4 and IPv6. Nowadays, Internet Protocol version 4 and Internet Protocol version 4 is still dominant in the market, but IPv6 more and more projects they require IPv6 support. So the reason is that IPv4 that's only 4.3 billion. It's a 32-bit addressing, so it's a 4.3 billion total address. So for the international address, actually that's not enough. There are a lot of IP address, even for IoT and a lot of terminals, a lot of devices, a lot of servers. So this IP address, after so many years internet technology development, the IP address has been exhausted. So currently there are a few kind of methods to address that. One is a network address translation. So they can, for public IP address, they can assign a public IP as a communication to all the international devices. And another domain is inside use. For inside use, they can use another dedicated IP address section. And that's the reason why it's even until now, there are still a lot of network deployed with IPv4. And the the reason to support IPv6 is that we can, nowadays there are more and more terminals, more and more sensors, IoT devices. The number is huge, and will be increasing year by year in the future. So some kind of big network, they already deploy. That's an interim stage called IPv4 and IPv6 dual stack. So the network can support both IPv4 and IPv6. And by default, the IPv4 devices will communicate will communicate with so the router will play the role of dual stack router, and it will work by default by IPv6. If IPv6 does not work, there's no response on the terminals, then they will downgrade to communicate with IPv4 until the communication is established. So currently we have some customers, they have some networks that's already dual stack, and we have some product that can support both IPv4, including the Only Hub Play. We can support the management and the streaming while both IPv4 and IPv6, and also that's a dual stack mode. The benefit of IPv4 v6 is that that's almost unlimited address. Instead of 32-bit address, it's 128-bit, so 4 times a bit, and the number of addresses is 340 antecedents. So it's a huge. You will not. It's almost endless. So you can use with IPv6. I think even that's a lot of devices. Devices is increasing dramatically in the near future. The number of address will be still be sufficient. And another is simplified auto configuration. So make a configuration and setting much easier. Do not have to with IPv6. You do not have to make a complex DHCP servers, and it's automatically assigns the IP address. It's make the configuration much easier. And also the multicast and routing, makes actually IPv6 is make the video transmission more reliable and more secure for the network. So it's more suitable for IPTV streaming. For some networks that require multicast and routing and network security premium service. The next one is network speed. So from time to time, we encounter some issues or some questions for the network speed, right? When we design the IPTV system, when we design the network, we need to know how many, what's the total bit rate of the content source. Typically, for instance, we have 50 TV channels, maybe 8 megabits for 1 TV channels. Then it's 4G. Then it's 400 megabits for the total bit rate. So in that case, for the 1G network, might be enough for transmission the content only. However, we need still, because a lot of customers nowadays they still use the internet service. They may use, they may see the live video from YouTube. They may see live video from Netflix, Prime Video, such kind of third-party apps. Such kind of apps still occupy large network bandwidths and streaming content. So in that case, they have to, in the trunk network, they have to use larger than 1G, right? They may consider to have a 10G internet access or even 25G internet access to match the internet service requirement on the facility. So 1G typically for access switch. The 1G connection between 1 room to the access switch, it should be fine because set-top box, if we have a properly IGMP snooping enabled, then the set-top box just at a certain time, it's just receiving the designated live TV channels. Even the live TV channel is 8 megabits per second or 10 megabits per second, is still acceptable, right? Even set-top box that's a 100 megabits ports are still workable for such kind of network. Yeah, so even for 4K, the bitrate might be a bit larger. Maybe some kind of 4K content in order to keep a very high quality. I can transmit up to maybe 38 megabits per second for each stream. But a 1G network still sufficient for such kind of facility. And the one point that we may need to pay attention to that the cable quality. So we'd better use a Cat5e or Cat6 copper cabling for up to 100 meters. If you're using very low quality cable, then you cannot transmit a very long distance, and it may have package loss even after for larger bitrate transmission. And also for the 10G aggregation, so typically from uplink from floor or from access switch to the uplink core switch, then you may need to use 10G, or you at least on the core switch of the hotel or the hospital, or the core switch must have the capability to have the 10G or even 25G uplink capability. Typically, such kind of uplink, 10G uplink use SFP plus. It's normally used. Although we can see that that's a 10G copper, but the transmission distance was dramatically reduced. So typically, SLP fiber used to the uplink for the 10G connection. 25G is the same principle. If you want to use a very high bitrate, very high internet service, then you may consider to have the 25G or even 100G as a backbone network connection. And such kind of connection typically is use fiber. Fiber is dominate typically. Even for some application, we have our Play. Actually, we also have some customized servers that can support very large scale number of terminals, for instance, 4,000 and 10,000. Then you have to use a server cluster or the servers with the SLP 25G network that can achieve the high bandwidth transmission. Especially you are using HRS streaming. HRS streaming, then the number of bandwidths, the number of egress bandwidths will be accumulated according to the number of terminals and number of subscribers. If you have 6G, if you have 6 megabits per second of TS stream and 1,000 subscriber, then it's 6G. So it's the network bandwidth is very large if you have a large number of subscribers in HRS streaming. Yeah. So usually it depends on the customer requirement. When we deploy, for instance, that's a new hotel, we need to decorate and we need to equip all the IPTV system, all the IT infrastructure. We need to consider how many rooms we have and how many internet, what's the total internet bandwidth we may need to support. So usually we will consider such kind of network situation, and then we will not overspend to the entire investment to the IT infrastructure, and we can at the same time maintain a stability of the network and IPTV streaming. So here the VLAN. Actually, I on the initial diagram, I have briefly introduced the VLAN function. So VLAN is just for virtual local area network. Local area network, everybody may be familiar with that. Even for a company that's an office, you have a local network, but that's a virtual local network. Virtual local network means you have a multi-switch connected together. You have a core switch, you have access switch. So such kind of switch actually, and even you have terminals that across different buildings, different layer of the buildings. You can bind them together via VLAN. So VLAN is a virtual local area network. It's like virtually connect all the terminals, all the Ethernet ports into the same network. The benefit is that all the terminal on same VLAN will share the same local area network. You share anything. You can share the folders. You share any content. And for an IPTV system, the benefit is that the VLAN, one VLAN, the content of UDP multicast string of the VLAN IPTV VLAN will not flooding to other networks. So if you have another VLAN, for instance, we have VLAN 10 for IPTV streaming. We have another VLAN 20 for Wi-Fi, for internet service. Even there's any problems on the VLAN 10 in the IPTV streaming, it will not influence the normal internet access. So this is such kind of main benefit for the VLAN separation. And typically we suggest that the IT administrator separate the VLAN for the IPTV, internet access, telephone service, or any other network management with different VLAN for management. Even for the administrator control, they can use a dedicated VLAN for management part. Another one is called IGMP. IGMP has been widely used for different for the IPTV system. So typically it's used nowadays. The most popular protocol is IGMP v2 and IGMP v3. This is based on IPv4. So it's typically IPv1 is very old, so nobody uses that. A lot of networks still using IPv2. The main difference is that IPv3 can support source SSM, source-specific multicast. That means even if you have two different source servers, and you can use the same multicast IP address, they will not conflict. And you can, on the receiving side, you can select designated source as a main source for the content receiving. And IPv2 does not have that function, but it has a basic function like jump, leave. So whenever that's a TV channel request, they will have send a join requirement, and then on the IP on the that's an IGMP query. On the IGMP query, actually, it will identify that request, and then push the string. So push the string to the designated Ethernet port. So this is typically how it goes. So only so with IGMP query and IGMP snowbean, then it can properly control the moving of all the content multicast strings, all the live TV channels. So only the required live TV channels will be sent to the designated set-top box and TV set, and it can it's running very efficiently. It will not transmit any other string to that room. So this is dramatically increase the efficiency of the data stream transmission. And when the TV set or the set-top box close or leave the viewing of the content, then it will the multicast stream will be released. Yeah, so this is it's working very efficiently to avoid any over data flooding on the network. If you do not have, if your switch do not support IGMP query, IGMP snooping, or you did not enable the IGMP query, IGMP snooping, then all the multicast, yeah, you can have a, if you have time, you can test by yourself. You can use one regular Ethernet switch, gigabit Ethernet switch. Then you connect, generate a multicast string to the switch. Then you will find that all the port will be flooding. All the multicast will run into all ports. So only the network with properly managed, with IGMP query enabled and then IGMP V2 or V3 enabled, then such kind of stream will be properly controlled and managed. Yeah, so IGMP snooping and IGMP query is it's a partner. They work together. Without the IGMP snooping, you will not be able to properly manage the streams in the network. And the IGMP query is like the server side. From time to time, it will monitoring the request. That's a monitoring request from the terminals. If that's an IGMP request, it maintain the transmission like a routing table. It's maintain the transmission to the port. So only the required port will transmit the required multicast IP streams. Yeah. So also for the besides the IGMP query, actually for a larger network, it might have a few multiple IGMP query. So in that case, we can typically assign a major IGMP query for the network with a minimum IP address. And for the rest query, you can either disable them, or you can either make it as a subquery. So in that case, it can still run efficiently. For the switch port, so in the network switch, sometimes we have we can find that it has a different role on the port. So by default, typically the role of each port is access mode, but there are other mode like hybrid or chunk. The major difference is that access port is just access to one VLAN network. So by default, that's one VLAN was assigned to each port. And in case you want to have have an uplink port that needed to have a multiple VLAN go across transmission to another switch, then you may use a trunk port or hybrid port. So hybrid port, a trunk port typically is a switch to switch transmission from access switch to core switch. You may need to transmit multiple VLAN via the uplink port. Then you have to use a trunk port. Another kind of special application is that one port with multiple VLAN, not all VLAN. Trunk carries all VLAN, but a hybrid means you can have tagged up multiple VLAN with that port. Yeah, so for some user case, they may have they may transmit different content to the same Ethernet port via different VLAN. Then such kind of hybrid port may be used. So typically for the VLAN port, we call the VLAN chunking. We have 802.1q tagging. With that tagging, then you can make a differentiation. And for the VLAN, one point that I want to mention is that the range of VLAN is typically from 1 to 4096. So typically, you can assign between this range, or according to the user habit of the IT network. within this range. Another most important topic is about layer 2 and layer switch. Typically, layer 2 it's much cheaper than layer 3. Of course, there are different type of layer 3 switch, but the layer 3 switch typically have more functional features. It has a routing function. It has a premium function other than that layer 2 switch does not have. So typically, layer 2 switch is used for the each floor. So it's used for the access layer switch. So typically, you can make the MAC address forwarding because layer 2 is not managed by MAC instead of IP. So you can assign it's working like a data link layer. So the traffic, like IGMP snooping, IGMP query, or IGMP snooping, such kind of features, they work in layer 2 switch. And also it has a capability to have the VLAN separation. So you can separate different VLAN. You can assign the role of each port as a hybrid trunk or access mode, depending what you need. And also for the sometimes for the IGMP snooping is typically when multicast string is running inside a network, especially for IPTV system. You have to enable the IGMP snooping properly in order to control such strings. Yeah, so that's such kind of layer 2 switch actually has a lot of basic features that can properly manage the data stream, separate the string network with different VLANs, and you can make an aggregation, some core aggregation or service. You can use multiple uplink cables to connect it to the core switch to have the redundancy backup. You can have the you can set up the DHCP server and relay function there. Yeah, so as a large network, you will see that you will consider the security of the network, the reliability of the long-term running. So link bonding or link aggregation may be considered. So what is link bonding? Link bonding is mainly used for redundancy or performance. Even for IPTV servers, we have a link bonding function that can expand the capability of the IPTV service streaming. You can use multiple. We can bind multiple output port to increase the bandwidth and or provide the redundancy function if the bandwidth is sufficient. Yeah, so the link bonding, typically if you consider the access switch to the core switch, you may connect multiple cables in order to increase the throughput of the uplink or increase the stability of the network. If one cable is loosened, then the other few cables can still be running properly. Or if that's a designated ports, data port, it will not affect other ports running. Yeah, so this is a link bonding. So typical link bonding, we are nowadays we run at weekend LACP 820.3 AD. It's called mode 4. Nowadays a lot of switch support LACP, link aggregation configuration protocol. So you can use multiple ports to connect between the switch, and it can both increase the throughput. You can use if you have a very large throughput. For instance, you have 4G, 4 cable connection and a 4G bandwidth. Then if you have reached to 4G, then we use all the cables for the, it will have a load balance of the transmission, data transmission. If you use a 2G or lower, then we can use a rest cable as a redundancy backup in case the neighboring port, the ports of the neighboring switch dead, then you can still using the rest port for communication. So it can greatly increase the security of the network transmission. Yeah, even if you disconnect one cable, the rest of the cable are still running properly. And there are other modes like mode 1 active backup and mode 0 round robin, but they are not so many, not so used nowadays. So have a full review of the entire architecture of the hospitality IPTV system. For instance, we have a 10-floor hospitality environment, and then the content is the same. We can receive them either from satellite, cable, terrestrial, IPTV source, and use only have 616 as a content source aggregation. We can receive them and encoding them and convert them into SPTS, UDP multicast. Each multicast carries one string. Remember that this is the feature, the main point for the IPTV system. You just carry one channels for each multicast string. Then it will not occupy too many bandwidths during the transmission. And on the IPTV servers, it's either play the role of disseminate the playlist of the live TV channels and provide a VOD content and provide them basic function of the hotel or other infrastructure introduction, and then push the string to the terminals. And on the central point, IT rooms or other internet maintenance rooms, that's the internet access point, either with 10G, 25G network FTTH broadband internet access. Then on each room, we have that's a core switch in the internet access point. And in each floor, typically we have we call the access switch. So the access switch actually, it may, if it's the floor has a lot of rooms, maybe you have multiple access switch, right? If you just have a limited room, then you can simply use one access switch, then connect it to the room's TV set, Android set-top box, and with different VLANs separated. And also you can connect it to them via the VoIP phones, and you can provide telephone service. You can connect it to some wireless AP for internet, Wi-Fi, internet access. And all this connect, and you can connect the core switch to another switch or network that of the IT room that IT and the administrator can designated manage all this network. They can configure the network port, firewall, and the security. Yeah, our IPTV system actually have we have a vulnerability configuration options. You can disable some kind of ports like SSH, Telnet, and even HTTPS. If you are using HTTPS, then we can disable the HTTP port. So there are a lot of different security options to enhance the network security. And of course, typically for a network with a high premium security requirement, typically on the right before the internet access, they will deploy a firewall there to avoid any breakdown or hackers of the network. Yeah, so for the for the summary, this is a complete network design 10-floor hospitality environment. We have core layer 3 switch with 10G, 25G, LACP bounded uplink, or if they don't need that, then we can have a 1 10G or 25G uplink. Yeah, we have a layer 2 switch that has a 1G uplink or 10G uplink, depending on your requirement. And also for the IPTV network, we can configure the IPv4, IPv6 dual stack, and configure DHCP, VLAN, and all different settings. Yeah, so this is a glossary for the webinar: DHCP, IPv4, v6, 1G, 10G, 25G, or even 100G. Yeah, and for the VLAN separation, to increase the security of the network. IGMP v2, v3, IGMP query to control the manager's multicast IP stream, and we have access chunk hybrid ports it can carry different number of VLANs. A chunk can carry all the VLANs. Access just one VLANs. Hybrid can carry multiple VLANs. Layer 2 and layer 3 switch typically layer 2 is used for the access switch. Layer 3 is for the core switch. And link bonding typically used to increase security or redundancy of the connection network between, especially the connection between switch. Yeah, here is a thing to remember. Yeah, so I will share this PPT slides after webinar, so all of you can have a further review of this content. Yep, so if you have any questions, you can raise now, and we can help to answer them.
Thank you, Terry, and thanks for the informative presentation. We will move to the Q&A section now. If you have any question, please feel free to raise your hand, and our product manager will answer it.
Terry, Otis, here are some questions raised in the chatting group. You can check the detail.
Let me check. Yeah, wait a minute, let me check. So we have some questions here. Yeah, so can I get? Yeah, so after the presentation, we can share this material to you, so that's no problem. So that's another question here from Mohammed. So currently, all your head-end IGMP query enabled as default, right? So the answer is that typically the IGMP query is enabled on the layer 3 switch. So if you have a layer 2 switch, you can have the IGMP query as well. So typically when you deploy a project with multicast running on the system, you need to enable the IGMP query and the IGMP snooping both in the corresponding switch. Yeah, so that's another question. If the customer using IGMP query as a core switch, it should be disabled from the head end. So typically, in each local area network, each VLAN, you can use definitely to simplify the configuration. Typically, you just enable one IGMP query and disable the. You can enable the IGMP query on the core switch and disable the IGMP query on rest switch. So it can simplify your configuration. Although that's a bootstrap mode for the IGP query, but that make the network more complicated. IGMP query from head end. Typically, yeah. So IGMP query. So typically, if you have a network that have IGMP query already, then you can disable the IGMP query on the head end part. Add and multiple source should connect to core switch. Another question is head and multiple sources should connect to the core switch or any other access switch with same VLAN. The answer is that you can connect it to any access switch with the same VLAN. Then this multicast stream will be transmit to the ports with the same VLAN. So it's not a problem. You connect as long as they are same VLAN, then you can connect it to any switch. You do not have to connect it to the core switch. May I know how many? So the next question: may I know how many channels can be handled by one IPTV server for HRS streaming? So this is a good question from Jason. So for the IPTV streaming, if you are using HRS streaming, actually it's it will all the content, all the multicast content will go through the servers. So we have so it will be converted. It will be spliced and convert small section RTS and HRS streaming. Then typically we have multiple options. Typically we have a IPTV server, IPTV module. There are different capability. We have supported. We entry level packet, entry level module that support from 50 to 50 TV channels, 200 terminals, to 150 or 200 TV channels to 500 terminals for the IPTV module. But for the server, we can customize depending on the requirement. We can use more powerful servers to support more TV channels and much more number of terminals. So once you have a project, you can reach out pre-sales team, and we can help to prepare a proposal for you. So next one, what about jitter and delay in IPTV system? This is a good question about jitter and delay. So typically, if you have properly configured the network switch, then the jitter is under control. So you will not see video breakup issues on the TV screen. For the delay, typically for IPTV system, if you want properly cached, typically the delay can be typical delay is 10 seconds. So we have like when we make a splicing, it may take 3 seconds, and that's a cache, maybe it takes 3 seconds, and that's 3 seconds for transmission and the decoding. So 10 seconds typically. But for super low latency system, if you configure the HRS and all the parameters with a minimum latency mode, then it can be 5 seconds. Connect to the VLAN. So that's another question. If connect the VLAN enough, how the stream will flow? Access to the core or access to reach the client? So if connected to VLAN, actually the stream will go through all the switch in the VLAN, in the same VLAN. Typically, the recommendation is that you connect the VLAN, connect the content source to the same VLAN in the core switch. This is recommended. But if if your on-site environment cannot achieve that, you have to connect to an access switch. It's still allowed. So you connect the access switch, the VLAN, and then this stream will go through the switch network into the same VLAN. So it will not. It will distribute because there's an IGMP query and IGMP snooping, and on the terminal side, no matter it's TV screen or setup, set-top box, it will have the IGMP request. IGMP, when there's an IGMP request, then the switch will automatically distribute the content to that TV screen. Yeah, so that's no problem for this infrastructure. Okay, that's another request to update the Sencore IPTV APK vision in Google Play Store. Yes, we can. We can make an update, latest update. Originally, we are using VLAN app name on the Google Play Store, but we can upgrade OmniHub APK into the Google Play Store to support YouTube, Netflix, such third-party apps. Okay, that's another question and a webinar soon about the product. We will double check about the IPTV system. If that's a new features released, big new feature released, possibly we can arrange another webinar. Okay. So here is another question. It's multiple clients playing the same channel in different time difference, more than a few seconds. It will be controllable. Actually, it's related to the buffering of the TV set. So typically, in the IPTV server side, it's just buffering the. It will buffer just three. It will make a slice, maybe 3 seconds length of HR stream. And on the decoding side, typically they will make a buffering of 3 seconds. So that's maybe the buffering makes a time difference, but typically it won't be very large. So we can, if that's a new project, we can double check how we can make the improvement. So that's another question about IGMP query on your head end. Some customer reported a problem of the timing of the IGMP leaf with IGMP query disabled. On your head end, set on the customer core switch if disable or IGMP snooping on head end problem. Actually on only have 616, we have an embedded switch. It's a bit different from typical our traditional head end. That the benefit of that is can flexibly communicate and the transmission of content inside of the chassis. So that's IGMP query and IGMP snooping was enabled by default. So for some user case, if you're just using 300 or 400 megabits data stream, then you can disable the IGMP query and the IGMP snooping in of only have 616 head end. Then this string will go through will go directory. This multicast string will run in broadcasting mode into your switch. But your switch have to enable the IGMP snooping and IGMP query. So this string can be properly controlled. If there's a data string, it's very large. We also have an alternative solution that we can offer you. We call the IP-02, the dedicated MUX board. That board actually can output the directory, the multicast IP stream without IGMP request. Yeah, so that's an alternative solution. So depending on what you need, we can provide a cost-effective solution. So middleware support or TV OS, Tizen OS. Yeah, so the question is about the end terminals or TV set operation system support. So currently, we our IPTV solution support a Samsung Hospitality TV within Tizen OS. We support Tizen 6.5 or above. We can also support WebOS 5.0 or above, and also enjoy all the latest Android operation system. So that's no problem. We have relative app, different app for Samsung, LG, and Android. Yeah, so depending on your requirement, you can select which app you need. Okay, that's another question. Please explain the IPTV regarding one hotel has different models TV, like hotel TV, Samsung, LG, and a few new TV which support YouTube, Netflix as default from LG, Samsung. Commercial hotel. Our IPTV system can support the hybrid TV models in different in the same IPTV network in the same hotel. So if you have latest models, then we can use as the latest app. And if you're using very old models, you can use old app. Even for the network, we support also the hybrid using of set-top box plus TV and hospitality TV. Yeah, so it can help our high customer to retain the investment. Suggesting client watch some channel. So suggesting client to watch the same channel in side-by-side display not recommended. In case a new TV not recommended and array. Oh yeah, so the question is yeah, side-by-side, definitely side-by-side watching of the TV, it's not a commonly happens, right? So yeah, at least you are in different rooms. Typically, if you have a two-room suites, typically that's a certain distance. Even usually that's at least a few meters from each other. So I don't think it will have much influence to the customer. Yeah, yeah. Practical in actual deployment, we did not see much time delay, but they do. If the TV you have pause it, or sometimes you have some TV has a big buffer, then we do have some maybe 1 second delay in some situation. Yeah. So that's a good question from Jim. So are you seeing AI or automation being used for IPTV monitoring for the detection or predictive maintenance? Yeah, so actually we have a group of engineering team. They are dedicated at AI. We call it edge computing or edge AI. And they are now making some research of such kind of edge AI tool that can help to monitoring the running status of our IPTV system and find out any fault or predict issues in the network. We have some premium research on that part, but currently that product is not ready yet. Once we have such kind of new product ready, then we can have a webinar to introduce what we have and possibly can meet your target application requirement. So in cafe, they are having side-by-side TVs. Okay. Yeah, yes, I understand. Yeah, so in some cafeteria, yeah, definitely they have side-by-side TVs. In that case, we have some technology called PTP, possibly that currently it's using in Praxis AV product series. Yeah, if you do have such kind of user case, and this is a real mandatory requirement for that designated application, we can make a further development to apply the PTP technology in IPTV system to achieve the accurate synchronization between all the terminals that are playing the same live TV channel. Yeah, we have that technology. We apply to some of the product, but currently it's not applied yet to our IPTV system. We should be able to, technically it's feasible. Yeah. Yeah, if the channel and the middleware are broadcast through STB, how will STB communicate with server? channel and broadcast through TV. How will you communicate with the server? Will it be Android, Linux, OS, Windows based TV? So currently for the set-top box, typically we recommend Android based operation system. This is almost dominated the market. Linux was an option many years ago, but Linux definitely the operation system is very old and it cannot support much new features. So Linux almost obsoleted on the market. Android operation system set-top box is almost dominate if you are considering to use a set-top box in your system. Yeah. So we have a model 8003 Android set-top box that is working perfectly with IPTV system and can support YouTube, Netflix. Yeah, we will share after the webinar. We will share the video link, so you can review and you can have more. If you have any more questions later on, you can also raise to us. Yeah, we will be very happy to answer these questions. Okay, so yeah. Okay, yeah, we will share the setup box details. No problem. Yeah, you can reach our sales representative, so you can he or she will help to send you details, data sheet, all the details at setup box, so you can have a look. Okay, so another question: do middleware has casting features? So currently currently Samsung and LG Hospitality TV, they have a casting feature. So once you enable the casting feature on the TV set, then you can achieve the video casting. And for the Android set-top box, currently it's not available yet. But if you need, then we can have other models options that has video casting features. But the price is different. Current recommended model is very cost effective. Latest Google certified set-top box. Actually, it has embedded it can have the Google Cast features. It's just like an app. It's running on the system, and like Samsung and LG, they also offer the options for the Google Casting. And currently, they do not have this technology. Do not need to use external dongle to achieve the video casting. So it's very user friendly. And also for the casting feature, actually, you still need to purchase a license option because we need to even your TV set has a casting feature enabled. You have to achieve the function that your mobile phone, the mobile phone of the guest at the room can accurate casting to the TV set in front of him or her. Then you have to use a casting feature. That casting feature actually it's with that casting feature enabled, then our IPTV server will play the role as a binding feature. Will bind once you scan the QR code on the TV screen, then your mobile phone and the TV will bind together. So you will not be able to casting your mobile phone video by mistake to another to the TV set in another room. So our casting feature actually address that pinpoint or customer requirement and released this year. Yeah. The casting feature management feature is centralized, but the Google Cast or AirPlay casting feature is embedded in the TV set. or embedded Android and in the Android set-top box. Yeah, but the management function, it's different. It's like the management function. It's deployed on the IPTV server side. It's a centralized management in order to bind your mobile phone properly to the designated TV set for correct streaming. Okay, so great questions and good discussion.
Okay, so does anyone else has any questions? Okay, so thanks again, Terry, and thanks you all for joining today's webinar. And we already mentioned, if you would like to receive recording of today's webinars or a copy of the lab presentation slides, please contact your Sencore sales representative or email us at salesonline@sencore.com. We appreciate your time and hope to see you at next webinar. Have a great day.
Okay, thank you. Bye.
Okay, bye everyone.
Thank you, Terry.
Thank you.
Thanks everyone for joining us.